I'm Sherry. I'm an ASM major. I'm Jarvis Kale. I'm an ASM major, and our project was the Bale weighing system.
So Jarvis, I'm looking over here. I guess this is the device, right?
Correct.
That is the weirdest looking bale I've ever seen. I guess you're just mocking up the bale.
Correct. That was to do our calibrations with to get our weights to make sure we were within a certain measurement.
Okay, very good. Well, I'm looking at well, I guess first we should start. Why would somebody want to know the weight of a bale?
Well, the whole idea behind our project was to implement bale weight along with GPS tracking through the field. That way we could bring this information together into one program. Excel is what we ended up using. That way you could potentially track your path through a bale and then get a weight, and this would give you a rough harvest or a rough yield for your forages, which currently isn't a real easy thing to do, being that your path varies throughout the field, usually when you're baling. And by incorporating this all together, it would essentially give us a yield monitor for hay or other forages.
Well, I'm seeing lots of pieces parts. This I recognize as a GPS receiver. What are the other pieces of the puzzle here?
Okay, what else the other parts we have here is we have our scale, or our bale forks, which are implemented with load cells for our scale, and also a Riker inclinometer. And these all come together into here. And the inclinometer is to make sure that we're level, being that the fields aren't necessarily level, and we can, with the hydraulic toppling, we can adjust our pitch of the bale forks to get an accurate measurement, and then that comes out into the scale. At the same time, we're using the GPS data, and it's all integrated into one. That way you can track your path through, hit log on the computer, and also print screen on your scale monitor, and this all comes together into Excel, and that gives you your date, bale weight, time, and then your coordinates within the field.
So what is this? Is this like just a regular PC? What is this?
No, we looked at several other as far as getting the tablets or what we wanted for this, and with our project, it's meant to be able to go further, which if you look here, like as far as adding the data, not necessarily using bale forks, but using other methods like a sensor inside a baler perhaps. And so we wanted a tablet that would be able to grow with the project itself. So we went with a mobile demand tough tablet, which essentially is a rugged, waterproof, weatherproof, dustproof system, and it runs on Windows operating system. That way we can use Microsoft Excel instead of trying to implement other apps or whatever. To make it simple was the reason behind it.
So CQ figured out how to take the signal from GPS,
yes,
signal from the load cell, and feed it to a spreadsheet.
Yeah, in a roundabout
How
way.
does that work?
Okay, so I'll start at the bottom here. We're using Digistar Transfer Utilities, which is what will decode what's coming out of your scale head. Okay, that's going into a raw data form with a timestamp and a weight, and you can kind of add a little bit more like a job number type deal, because it's a universal type deal. And then we're using FarmWorks Mobile as well, which will allow us to harness our GPS capabilities into a job format where you can go down to field, farmer, acreage, plot paths, drop points, whatever you need to do there. The only problem was we first started out, this was at 38,400 baud rate, and it crashed FarmWorks Mobile every time we hooked it up because it's pushing so much information. So we've knocked it back down to 19,020, 19,200. And that, it works flawlessly. There's no lag. It's instantaneous. Like you said, you hit print screen, you hit log, and it drops your points.
So I'm just guessing, maybe you haven't really studied baud rate too much before you started this project.
Had no concept of baud rate.
Right. So I think this is a great project because, well, you knew a lot to be able to get going. You realize you don't know everything, but you know how to learn. You just did it.
Well, and it come down to, using my skills as far as research, knowing how to talk to people is a big thing. You don't want to go in bullheaded, and I spent 65 or 70 hours on the phone on this project just talking to Digistar, Mobile Demand, Library Crop, which is our supplier for most of this, and just getting answers, which worked out pretty well, and it's successful.
Sounds like a very good networking opportunity. You get to meet a lot of people from a lot of different companies through the process. And what we're going to do is, this is a key little piece. I guess that's a bolt-on keyboard.
Bolt-on, what they call a QWERTY keyboard. The reason why it's disconnected right now, this is supposed to be able to be locked into either one of these harnesses while attached to the bottom of the rod. I took the adapter plates out because the problem was we weren't able to harness our COM3 port or our charging capabilities. So as you can see here, when you got her plugged in, it's saying it was getting power through our cable, but through the COM port on the back side, it wasn't receiving connectivity through these plates or pins. So we took it off. As soon as we did that, we had no more technical issues. It wasn't crashing because it wasn't getting, it would go into like a non-responsive mode because it knows something's there, but it can't get it.
Sounds like a good troubleshooting problem.
Exactly.
And you navigated the problem.
Yeah.
So the total cost was $8,000. Is that for the hardware software package?
That was a combination of our Bale wings system from previous years and kind of it was a continuation, like a continuous count of what we're spending. There's some things that are not included on there, but that's pretty accurate count there. And a lot of what we got here is top of the line, so we're not going to have problems with technicalities. So
Jarvis, in the end, how close is this to being done? Like, here's the solution, or is almost the solution?
Well, this is almost one solution potentially as far as the Bale forks. We have this operating. This could be implemented now with some data as to understand how to work the programs and everything. It is functional now, but ideally this project in the future would go towards, say, a Bale sensor, something that's remove some of the steps from the process. That way you wouldn't have to stop every time with the Bale forks in the field. Something where you can do on the run, where all you have to do is stop to get an accurate weight, hit the button, and then it's there. Instead of taking
if you scan over to our PowerPoint we got going here,
we have some.
This will kind of tell you where we're going on future work.
I did see your classmates were working on an RFID tag for Bales. So I could see that integrating very nicely with this. So that, because you're going to say, where did the Bale come from? They will tag the Bale, but you can then say, well, here's where it came from, how much it weighs, and then do what
Yeah, we were trying to limit the amount of man-hours that went into our collection of our bales and our recording of our scale. So we kind of wanted to get it down to you're picking the bale up, you're loading it, and weighing it all at the same time instead of picking it up, dropping it, coming back and picking it up to load it later.
A pretty unique solution. Lots of electronic devices. I suppose some days that was fun. Some days it was just like, I'd rather be bald so I don't have to pull my hair out.
Exactly.
I don't know. But anyway, thanks for the job well done. We're here at Purdue in the Department of Ag and Biological Engineering.